In this video we're going to have a look at permutations and factorial notation. So first of all, permutations are defined as the number of arrangements of objects or symbols. So what we'll have a look at first of all is some possible ways to interpret number of arrangements and whether or not they are permutations. In this first example we're trying to arrange as many two-digit numbers as we possibly can based on using the digits 0, 1, 2 all the way through to 9. If we arrange the digits 0 through to 9 in an orderly manner, like in this table shown here, we can see that there are 100 two-digit arrangements. That's quite straightforward because we've got 10 digits, 0 through to 9, and each one of them can be followed by 10 digits. So we've got a table that measures 10 by 10. So there's 100 arrangements. But this assumes that we can repeat digits, and this is where we need to be careful with the definition of permutations. Permutations is based on the number of arrangements from a set of elements. So if we define our set to be 0 through to 9, we can only use the numbers once if they appear once in that set. So let's assume that our set of elements is 0 through to 9, each digit only occurring once. The permutations are restricted because we can't have repeat digits. So in our table, similar to what we had before, the numbers that are missing are numbers like 0, 0, 1, 1, 2, 2. In other words, anything where there's a repeat of the digits. So in this instance, we can see that there are 90 possible arrangements. Again, there are 10 digits we can use at the start, 0 through to 9. But once we've used one of those digits, there's only 9 that can be used in the units column. So the total number of arrangements is 10 multiplied by 9, which is 90. Now let's have a look at arranging different elements. In this case, we'll arrange letters from the word cat. Now it says how many words can we make from the word cat. Now just to clarify this, we'll define words to be simply a rearrangement of the letters. So whilst they may not appear in the dictionary, we'll define words for the sake of this example as the arrangement of the letters C, A and T. Well, first of all, we need to consider what could happen in the first position. So we've got 3 letters, so we could have a word starting with C, we could have a word starting with A, or alternatively one starting with T. Now because we're not allowed repeats, in the second position there are only 2 characters we can use for each letter. So for example, if C is the first letter, we can only use an A or a T in the second position. Likewise, if A is the first letter, we can use a C or T, and if T is the first letter, we can only use an A or a C. For the remaining letter, we've got one choice for each one of these examples. So in the first instance where we have C, A next to each other, the only alternative is a T. And we can see for the following examples, which is shown in green, that each of those letters, there's only one choice. If a A or C have been used, we can only use a T. If a T and A have been used, we can only use a C. And if a C and T have been used, we can only use an A. So how do we express the number of ways we can rearrange the letters of the word cat? Well, in the first instance, when we put down the first character, there were 3 choices. So we could have used a C, A or T. Once we've picked a character, there's only 2 options. And then we go to the last character, there's only 1 option. So we put down 3 multiplied by 2 multiplied by 1. And that gives us an answer of 6. Now if that doesn't quite make sense, there's another way to look at it. What we'll do is we'll have a look at a tree diagram. So the way we use a tree diagram is we consider one letter at a time and we use branches to indicate the possibilities. So for the first letter there are 3 possibilities as before, C, A and T. Now for each one of those choices, for the second letter there are 2 options. So we put 2 branches out from each of our first choices. So for example, if we use C first, we could then use an A or a T for the second letter. Likewise, if we used A first, we can use C or T for the second letter. Now for the third letter, there'll only be 1 branch because we've only got 1 option left. So from C and A, the only option left is a T. Likewise, from C and T, the only option left is an A. So in each one of these cases, we started off with 3 branches, then 2, and then down to 1. And then we put all of the final arrangements on the right-hand side, and we can see here all the possible ways of arranging letters C, A, and T to form different words. So that's 6 possible arrangements, and hopefully now from the tree diagram it's a lot more logical that the multiplication process takes place. which is 3 multiplied by 2 multiplied by 1, and each of those numbers indicating the choices that we've got as per the tree diagram. Now when we write out a multiplication of consecutive integers all the way down to 1, in this case 3 times 2 times 1, there's a quicker way to write that, and we use factorial notation. So in this case, 3 factorial replaces 3 multiplied by 2 multiplied by 1. Let's have a look at another example where we're trying to rearrange the word west into as many different arrangements, or we'll call them words again, as possible. So given we've got 4 letters, in this case W, E, S and T, we can start off our new words with the letters W or E or S or T. And for the sake of this diagram, we can see that the remaining 3 letters after W, E, S and T are unknown at this stage. Now we'll go with the W first of all, and if we choose W to be our first letter, then our second letter could be an E, or it could be an S, so we could have WS, or it could be a T, in which case we could have WT. So that's our options for the second letter, assuming we're starting with W. So let's assume that the second letter is an E. Our third letter could be an S, and then it has to be a T after that, or if the third letter is a T, it has to be an S after that. So there's 2 options we can see in green, assuming we start with a W and then an E. Let's have a look at some other options as well. If we start with a W and an S, then the remaining 2 letters would be E and T or T and E. And if we started with WT, the remaining letters could be ES or SE. So we'll put all of those W words in a first row together. And likewise we'll repeat the process with E as the first letter, and look at all the options there. And then S as the first letter, and then T as the first letter. So it might be wise when you're looking through these to stop, have a look and see if you agree with the arrangements and how it's been done. So in terms of a quick calculation, this is very similar to what we did with the word cat. In this case we've got 4 letters to choose from in the first position. So to work out the number of ways, we'll start by going 4, and then we'll multiply that by 3, because there are 3 letters we can use for the second position. And we can see here in our example, we'll assume that W was the first letter, and we can see that our 3 options for the second letter are E, S or T. And then once we've chosen one of those, we'll assume that we chose, for the sake of this example, letter E. There are 2 options for the third position, in this case an S or a T. And then assuming that we chose S for our third letter, there's only 1 option. In this case we can see in yellow that would be a T. So we have to put down all these arrangements because we can see clearly from our table or our chart that there's 24 possibilities. So it's 4 multiplied by 3 multiplied by 2 multiplied by 1. And another way of saying that is 4 factorial. And 4 factorial equals 24. So rather than write down all the possibilities, which is going to increase significantly with more letters, the quickest way to work it out here, we can see without any repeats, is to use 4 factorial, and that comes to 24 ways to rearrange the letters of the word west. So to summarize that, if we're arranging n different objects into all the different possible orders, we use n factorial. So that's n multiplied by n minus 1, multiplied by n minus 2, etc., all the way down to the number 1. In our example before, we saw the word cat, and when we rearrange the letters from the word cat into all the possible different arrangements, we use 3 factorial, which is 3 multiplied by 2 multiplied by 1. Another example might be using the 5 letters of the word frost. Now just like in the word cat, none of the letters are repeated, so we can use this notation 5 factorial to determine the number of possible arrangements from the letters from the word frost. So 5 factorial, as we can see here, is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and that gives us 120 possible arrangements for the letters from the word frost.